Hi everybody. Today we'll be solving Leetcode 2919. This question is very interesting. It's tagged as medium, but I feel it's a bit on the harder side. So let's understand the question. We are given we are given an array of integers 23002 and an integer k is equal to 4. Now we say an array is beautiful only if any subarray of the given array of size 3 or greater than 3, that is, let us say this subarray 230, the maximum of this subarray, which is 3, should be greater than or equal to k. So as we can see, in this case, it is not, or any other subarray 300, it's not. So now this is not a beautiful array. How do we make it a beautiful array? For making it a beautiful array, all I could do is increment plus 1 here. And if I do an increment of plus 2 here, now the new array is 2, 4, 0, 0, 4. Now let us take any subarray of size 3, which is 240. The maximum is 4 here. Then 400 maximum is 4 and 004. In all of these cases, we can see the subarray has a maximum element which is greater than or equal to k. So this is our beautiful array. Now we have achieved converted this array to this array using three operations, which is plus one, and each plus one is considered as an operation. So right now we have done three operations. Is there any other way to convert this given array, a beautiful array? If I convert the array as 2, 3, 4, 0, 2, that means I have done an operation of plus 4 on index 2 to get the new array. Here, if you can see, any subarray of size 3 has a maximum value of 4, 234 or 340 or 402. So this is also a beautiful array, but to get this particular array, we have done four operations. So our answer is 3, as we need to find out the minimum number of operations needed to convert the given array as a beautiful array. One thing to notice is it is given subarray with a size of 3 or more. So if at all we make sure that the array is beautiful for size 3, for any other greater size will also be implied. For example, if I take the subarray of size 4, 2300, it can be easily divided into two smaller subarrays like 230 and 300. If this is a valid beautiful subarray and this is a valid beautiful subarray, we can say that this will also be a valid beautiful subarray. So we can make sure that all subarrays of size 3 is beautiful. Then automatically any subarray which has size more than 3 will also be beautiful. Let us consider the following subarray x0 to x6, which is having 7 elements. Now I want to make this subarray a beautiful array, and I'll consider the first subarray of size 3. In this case, let us say this is a valid subarray. That means x0, one of these values, x0, x1, x2, is greater than the integer given k. Okay, so how many operations did we need to make it optimal for just the first three? Is 0 plus. Now, if I want to find the total number of optimizations which I need to do, then that would be let us say a function f. And as this subarray is valid, now I only need to worry from this subarray starting at index 1. Okay, now what would be the f of 1 is, let us say this particular subarray is not a valid subarray. That means x1, x2, x3, all of them are less than k. So in our case, which one should we choose to increment? Either x1 is a valid option, x2 is a valid option, as well as x3. And right now we do not know which one would give us a complete correct answer for the whole array. So there is no other way, but we need to calculate for all of them and take the minimum of them all. So f of 1 would be, let us say if I am incrementing x1, how many operations would I be doing? I should be reaching k minus x1. So these many operations I do, plus I'll call this function on 2, as we know when x1 is incremented, we know that this particular subarray is fine, but we don't know about this one. Okay. Similarly, when I increase x2, it would be k minus x2 plus I would be calling the function on f of. Now, in this case, when x2 is incremented, we know this is a valid subarray. This is also a valid subarray as x2 is present, but we don't know if this is a valid subarray or not from x3. So it would be f of 3. And the last one, if I choose to increment x3, then it would be f of 4. So I need to find the minimum of all of this and return as f of 1. So this is how we have divided the complete problem, which starts from 0 to f of 2, f of 3, f of 4. As we can see, we are using recursion here, that the bigger problem has been divided into a smaller chunk and being called on that. We'll write the recursive code first, then try to memorize the value such that we don't have to recalculate the subproblems. Now, what is the border condition here? Now, if we can see f of 5, that is, when I've reached the end of this index, that there is the subarray of size 3 is not possible, then there is no operation to be done there. So f of 5 would be 0. Let's code the approach which we have just discussed. Let me first define a helper function. Helper. This will take the starting index from where we are forming our subarray and the array, the original array, and the integer k. Okay. Now, from our main function, we return helper called on the first index, which is 0, nums and k. We'll write the border condition, that is, if the index is greater than index plus 2 is greater than or equal to nums dot size. That means we cannot form the subarray of size 3, return 0. If we are able to form, and we need to check if the subarray formed, is it already beautiful or not. That is, one of the element is greater than k, nums comma k. We'll write this valid later, but if it is valid, then I simply need to return the helper function called on the next index, start plus 1 comma nums comma k. Great. Else, that means if the current subarray is not valid, we have three cases. Let us say the first one is we are incrementing the as considered x1 value. Okay, so in that case, how many operations do I need to increment? Nums k minus nums of start plus you call helper on start plus 1 comma nums comma k. Yes, and we repeat the same one as answer to here start plus 1. I'm selecting the second index to be increased, and here it is the third index, second and third. This is exactly following this particular method. Okay, now here we return the minimum of answer 1 comma minimum of answer 2 comma answer 3. We return the minimum of these three. Let us write the is valid, which is returning a bool is valid. What all it is taking the same function signature. So if my maximum value among which three nums start and nums start plus 1 comma nums start plus 2, if this maximum value is greater than or equal to k, that means one of them is greater, we return true, that it's a good subarray, else we return false. Okay, now let's run this function. Okay, this is a mistake, answer 3, run. Okay, Now, when I submit this, I'm expecting a TLE because we have not used memorization anywhere. Yes, very good. We got a time limit exceeded. Now we need to figure out how to memorize this particular helper function. We are calling this again and again. And the general trick which I use is I see in a function signature, which is the how many variables are there. In our case, start is changing with every call, but nums and k is always the same. This doesn't change. So there is only one variable. We define a vector. If there were two, we would have defined a 2D vector. Now it's only one variable. We define a 1D vector. I'll call it DP, short form for dynamic programming. Let me initialize this one here, and I will do DP resize. The size of the DP is nums.size, comma. I will initialize to any random value which is less than 0 as as -1. Now, after the boundary condition, I'll check is this particular DP set anywhere. So DP of start. How do I check if it is set anywhere? If it is not equal to -1, which we have initialized, I can simply return DP of start. That means somewhere below it on start, this DP has already been called. If it is not called, it will enter the lower functions and where I'll be saving the value of DP of start. Okay, let us see if our compilation is fine. And submit. Okay, what is the error here? Looks like somewhere I'm using in. Okay, this should have been long. Submit. Okay, the answer is accepted. Thank you for watching until the end. Please like, share, subscribe.